guys, it's Chi again, and you're welcome to another knowledge field analysis with Chi. Previously, in the introduction to structure analysis lesson, we saw that structures could be statistically determinate or indeterminate, and I said I was going to explain further in subsequent videos. So here is the video. In this video, I'm going to be explaining what statistically determinate and indeterminate structures are. But for better understanding, I am firstly going to give you the different types of beams. We have different types of beams based on geometry, equilibrium conditions, and types of supports. The type of beam based on geometry is not our major concern for this lesson, so I am not going to dwell on it. I'm going to dwell on the types of supports and the equilibrium conditions. So we're going to start with the different types of beams based on the types of supports. They are classified into 6. We have the simply supported beam, we have the cantilever beam, we have the propped cantilever beam, we have the fixed beam or built-in beam, we have the overhanging beam, and lastly the continuous beam. So I'm going to explain all 6 of them to you, starting with the simply supported beam. Now, the simply supported beam is simply a beam which has a roller support at one end and a hinge support at the other end, like this. So this line simply represents the beam, while this is a hinge support and this is a roller support. So this is what a simply supported beam looks like. We move on to the next one, which is a cantilever. A cantilever beam is a beam which is fixed at one end and free at the other end. This beam has one end fixed and one end free. As usual, the line represents the beam. You can see that this is a fixed end, this is a fixed support, while the other end is a free end. You can see there's no support there, that's why it's called the free end. So that is what a cantilever beam looks like. Moving on to the third one, which is a propped cantilever beam. A propped cantilever beam is simply a beam which is fixed at one end and supported at the other end, either by a roller support or a hinge support. So you can see that this end has a fixed support, the other end has a roller support, and the line represents the beam. So that is what a propped cantilever beam looks like. Moving on to the fixed beam or the built-in beam. The fixed beam is simply a beam which has both of its ends fixed. It's usually drawn like this. So you can see that this is the fixed end, this is the beam, while these are the fixed supports which is located at both ends of the beam. Talking about the overhanging beam. The overhanging beam is a beam which has its end portions extending beyond the supports. It could be just one end or it could be both ends. So what I mean is, the straight line is a beam. It could be just one end which is overhanging, meaning at the other end it will not be free, would have a roller support or a hinge support there, and here and here, and leave the other end overhanging. So this diagram represents overhanging just at one end. When it has to do with both ends will be overhanging. So we'll only have supports along the beam but not at its end. Both ends will be left overhanging. So that's what an overhanging beam is. Last but not the least, talk about the continuous beam. The continuous beam is a beam which has 2 or more supports distributed along its length. Diagrammatically, it's represented like this. We have supports, a support, a support. So this is what a continuous beam is. Now that we've known the types of beams based on the types of supports, we're going to talk about statistically determinate and indeterminate structures. A statistically determinate structure is one which satisfies all 3 moments of equation of equilibrium. This simply means it has maximum of 3 reactions. And the equations of equilibrium we saw from our previous lesson are summation f of x must be equal to 0, summation f of y must be equal to 0, and summation of m must be equal to 0. So if the reaction forces can be calculated using these three equations of equilibrium, then the structure is said to be statistically determinate. And this is vice versa for a statistically indeterminate structure. If the reaction forces cannot be calculated using the equations of equilibrium only, then the structure is said to be statistically indeterminate. Also, if the number of unknown exceeds the equations of equilibrium, then the structure is statistically indeterminate. But if the number of unknown does not exceed the equations of equilibrium, then the structure is said to be statistically determinate. I'm going to give you a few examples of statistically determinate structures and statistically indeterminate structures. So for statistically determinate structures, we have a simply supported beam. So you can see the reason why I gave you firstly the types of beam. So a simply supported beam has a pinned support and a roller support. From our previous lesson, a pinned support has 2 reactions and a roller support has 1 reaction. So adding them up together, we have 3 reactions. And we said if the reaction forces does not exceed the number of equilibrium equations, then it is statistically determinate beam. And the number of equilibrium equations are 3. And for a simply supported beam, the number of reactions are also 3. That means that a simply supported beam is a determinate beam and also a statistically determinate structure. Another example is a cantilever. You can see that a cantilever has a fixed end and the other end is free. And a fixed support from our previous lesson has 3 reactions. So for a cantilever, it has 3 reactions. That makes it a determinate beam. For statistically indeterminate beams, we have a propped cantilever. You can see that one end is fixed and the other end is supported either by a roller support or a hinge support. If it's supported by a roller support, it has 4 reactions. If it's supported by a hinge support, it has 5 reactions, because the fixed support is 3 and the roller is 1, which makes 4, and the fixed support is 3 and the hinge is 2, which makes it 5. Also, we have continuous beam or fixed beam. So that is all about statistically determinate and indeterminate structures. Remember our types of beam based on equilibrium conditions. We have 2, which is statistically determinate beam and statistically indeterminate beams. So as earlier said, statistically determinate beams are beams which can be calculated using the 3 moments of equation of equilibrium only, while a statistically indeterminate beam is vice versa. So examples are the same that I just gave you on the determinate and indeterminate structures. So that'll be all for today's lesson, guys. I hope you learned something. Don't forget to subscribe to my channel, like, and drop your comments. Thank you.